Good morning, Chief Guest Chancellor Dr. Mrs. Elizabeth Verghese, distinguished guests Mr. Harish Murthy, Mr. Akhil Gopinath, Mr. Mohammed Awais Jamal, faculties, and my fellow students. I, Rachel Andrews, a second year student of Computer Science and Engineering from Hindustan Institute of Technology and Science, and on behalf of my fellow students, I'm truly honored and delighted to welcome you all to the MATLAB workshop and webinar hosted by the School of Computing Sciences and School of Sciences and Humanities. I would like to call upon Assistant Professor Dr. Simon Raj from the Department of Mathematics to welcome the dignitaries.
Most respected Chancellor Dr. Elizabeth Verghese, Pro-Chancellor Anand Jacob Verghese, Pro-Vice Chancellor Alexander Jesudas, HOD CSE Department Dr. Angeline Geeta, HOD School of Science and Humanities Dr. Ramesh Babu, HOD Department of Mathematics Dr. Nagarajan, and researchers and my dear students, a very good morning to all. It gives me immense pleasure to welcome all for this online re-onboarding meeting for the academic year 2020-21, followed by a webinar on graph and network algorithms using MATLAB. This program is arranged whenever a new version of MATLAB is released by the Mathworks products. About this program, in the session 1, Mr. Harish Murthy and his team will conduct an online workshop how to install the MATLAB software and explain the new tools introduced in 2020B for the students who are new to MATLAB. In the session 2, Mr. Akhil will explain construction and analysis of graphs and how to draw 2D and 3D graphs visualization in MATLAB, and also he will demonstrate on real life application using MATLAB. The outcome of this program, students can able to install MATLAB software in their laptop and also learn new tools introduced recently, and with the help of MATLAB, the students can able to draw graphs, do analyze networks, and they can apply it in the real life problems. With these few words, I extend a warm welcome to all presented here. Thank you.
Thank you, sir, for the warm welcome. Now, I would like to call upon Mr. Harish Murthy, who is an education customer success specialist and the point of contact between the Institute and the Mathworks, to talk about the installation, the tools required, and the new features of MATLAB 2020B.
Hello all, good morning. My name is Harish and am I audible?
Yes, sir.
All right, sir. Thank you all, sir. Thank you for organizing this, and this looks really good. All right, and so can I go ahead and share my screen?
Yes, sir, please share.
All right, so one moment. Just a moment, sir. I'm just having some trouble. All right. Sir, I am not able to share my screen. So when I click on the share screen, nothing is happening. Is there anything that has been disabled for the share screen?
No, sir. Even recently, Akhil has shared his screen.
Okay.
Akhil from Mathworks, he shared his screen.
Okay.
Or shall we have first webinar, then we can have a workshop in the second? Can you solve the issues, sir?
Yes, sir, definitely. You can start off with Jamal, sir. Would that be fine if Jamal can give an overview of the portal, and he's going to talk about the 2020p toolboxes as well. Suppose that Akhil can start off.
Okay, sir. Okay, Jamal,
Right.
Mr. Jamal, please share your screen and start, please.
Sure, sir. Let me go ahead and share the screen. All right. I hope you all are able to see my screen. I've shared the presentation with the first slide stating campus-wide license management.
Yes, Jamal.
All right, let's get started. So today we are going to be focusing about the individual license type out of the 3 license types that are available on your campus-wide license. Now, the reason we are focusing on the individual license type in the re-onboarding is the other 2 license types are still managed by the administrators. That is the network license types for labs and classrooms and the designated computer license type for individual computers inside the university. Talking about the individual license type, this particular license type allows all the users, be it the students, all the faculty members, to install MATLAB on their personal machines. And you can install MATLAB on 2 different machines as well, be it a desktop or a laptop. In order to get the users associated with the license, we do not want to give manual work to the administrator in terms of adding the users. So we have created a automated workflow. Now, this workflow would help the end users, be it the students or the faculty members, to associate with the individual license type by themselves. The entry point for this workflow is a portal that we have specifically created for your university. And we are going to be talking about this workflow, and we are going to be talking about what are the other resources of this portal or the benefits of the portal. Now, to get started with, this is how a demo portal looks like. But after this presentation, I will be taking you all through the live portal, which is currently active. The users who want to associate with the campus-wide license would go to this website on their browser. Then they will click on the sign in to get started page. After which, the system would ask the users to log into their Mathworks account. Now, new users who do not have a Mathworks account can select the option create account and then fill in a small form with email address, first name and last name to complete creating the Mathworks account. After which the users would log in again and they would be automatically associated with the license. As you can see, within 3 or 4 simple steps, a user is associating with the individual license by themselves. Now, how we manage that, we'll talk about it in the upcoming slides. But the primary requirement here is to use an email which has been provided by Hindustan Institute of Technology and Science. So even if you are logging into the Mathworks account, that is, if you have an existing Mathworks account at the second step, you need to use the university provided email. Or if you are creating a Mathworks account as a new user, you need to use an email provided by the university. Now with that, since this is the primary steps to get associated with the license, which opens access to installing MATLAB or all the other features and benefits that we are going to be talking about today, Let's take a moment here to see if we have any questions in terms of the portal workflow or the association itself. So users, if you have any questions, please feel free to unmute yourselves, or you could also post the questions on the Teams chat window. We would be monitoring that as well. If there are no questions at this stage, we would be proceeding further. Once a user installs and activates an individual license on their own computer, they can use MATLAB without internet connection and without having to log into the Mathworks account. So MATLAB works like a offline software. You can simply start it without having to connect to internet or logging into your Mathworks account. Ideally, this is true until the license file needs to be reactivated. Now, before the license expires, you will see a notification message within the MATLAB window asking you or telling you that the license is expiring. And in order to renew the license or reactivate the license for another term, which would be ideally 1 year, you can select the help section on the top right and then select licensing and finally activate software. After you click on activate software, you would be asked to log into your Mathworks account again, and that would complete the reactivation automatically, and you should be good to go for another year. Now, do not worry if you have missed out this 15 days window for reactivation, and if you have missed out on completing the reactivation within MATLAB. Because what you could do is you could simply start the MATLAB shortcut and it will directly take you to the activate software because it will recognize the current license file has expired. And when it directly takes you to the activate software, you simply log into your Mathworks account and you complete the activation. Coming to the mechanism on how we allow the users automatically or what kind of system we have here. So we have an inbuilt system of email domains, which either allows a particular domain or blocks a particular domain. Currently, for Hindustan Institute of Technology and Science, what we have is we have the domains such as hindustanunif.ac.in, which have been added in the allowed list. And because of that, the subdomains such as student.hindustanunif.ac.in are also added in the allowed list. And this ensures any user who goes through the portal workflow that is associating with the license is allowed automatically without having to be approved by anyone. From administrators side, administrators can log into mathworks.com, and under individual license, you have the allow or block email domains. And here you could check what domains are allowed and if any domains are blocked. In order to make changes to this list, you can select open a service request and share the domains with us so that we could add it to the allowed list or block list based on your preference. Coming to the transitioning part, I understand some users may be already having MATLAB from their previous license, which could be a trial or a student version or an academic version. This goes for both students and faculty members. So what we suggest is if you're having any installation from an unknown source, then we would request you to uninstall that. And then step one would be to first associate with the license and do a fresh installation. If you are a user who had installed MATLAB from mathworks.com, then you need not uninstall MATLAB. You can simply rerun the MATLAB installer, and it would be smart enough to recognize that you already have an installation. Like in this case, the user had already installed MATLAB and Simlink, and the installer is giving the option of installing all the other toolboxes. Now, this method can also be used, that is, to install additional toolboxes onto an existing installation of MATLAB. Example scenario would be a user on the first time just installed MATLAB and Simlink, but later, after a few days, wants more toolboxes. So you simply rerun the MATLAB installer and install the additional toolboxes. That would be about the individual license type. And before we proceed to the additional license options for our advanced products, let's see if we have any questions. All right. It seems there are no questions for now. So I will move on to the additional license options. Harish, if you're still able to hear me, please acknowledge.
Jamal.
Okay, great. All right. In terms of additional license options, with the campus-wide license renewal, we also opened access to our advanced products. So earlier, you just had MATLAB and toolboxes. Now, with the campus-wide suite, you would have access to all the toolboxes along with MATLAB. And simultaneously, we have also shared access to our advanced products. The first one is MATLAB Parallel Server, which is distributed computing. An example for this product use would be, let's say you have a compute intensive job, which is taking a long time to run on your personal machine or your own machine, and you want to use more compute power to complete that job faster. Then you could set up MATLAB Parallel Server on a group of computers, which would be acting as a cluster. And that job would, of course, be processed faster and the results would be returned to you sooner. In terms of the setup of this product, since in the interest of time, in terms of the setup of all the advanced products, we may need to have separate sessions with the users who are interested to set up these advanced products. Administrators can forward those or direct those users to contact us, and we'll guide them separately. The other advanced products we have is MATLAB Production Server, which is to, I would say, host an algorithm or analytics into web or database as production enterprise applications. These are hosted on dedicated servers. That is, if you want it on your own hardware, or you could also host this in the cloud. Now, this then can be accessed by or utilized by many users remotely. The other advanced product we have is MATLAB Web App Server, which is to create and share app designer based MATLAB apps and simulations of Simlink as interactive web apps. End users who would be running this MATLAB Web App Server apps need not have a MATLAB or Simlink installation or license, and they can simply access this on the browsers. Next, we have Polyspace, which is used to verify your code written in languages such as C, C++, and ADA. And Polyspace products can be used to highlight any defects on these languages, and also to run exhaustive testing on your code to prove the absence of runtime errors or any concurrency issues or any security vulnerabilities. Finally, we have Roadrunner. This is an interactive editor which specifically lets you design 3D scenes for simulating and testing automated driving systems. In terms of access of this product, these products should not be appearing on student or faculty member account Mathworks accounts initially, but only the administrators would be able to see this initially. But as in when we get requests from users who are more interested in these products, we could help you get access, and we could also help you in setting up these products. That should be on the presentation side. And before we move on to the portal demonstration, please let me know if there are any questions on the individual license association or any of the advanced products, or how we authenticate a user from the university and so on. Any questions on what we have covered so far? I believe we could get started with the portal demonstration if there are no questions on the presentation side. Let me bring up the portal. Please bear with me. All right. Harish, please confirm if you are able to see the screen again, the screen which I've shared.
Yes, Jamal.
All right. Now, talking about the portal. So what we saw earlier was just a demo screenshot. This is the actual portal which is currently live. The portal itself, or the website, this website, what we are seeing is created, hosted, and managed by us. So there's no issues on hosting. Of course, we will share this portal link at the end of this session so that users can use it to get associated with the license, or also use it for the other features. The name of the university and the logo has been updated already. Talking about the features of this portal, of course, the first one is the sign in to get started feature. If I click on that, ideally, it should ask me to enter the Mathworks account credentials, but since I've currently logged in already, it would say that the license is now linked to the Mathworks account. Any new users, when you select sign in to get started, you need to enter your Mathworks account credentials if you have a Mathworks account already. If not, you could create one. In terms of other features of this portal, we have a list of available products. So if I click on this, it will show me all the products that are there on the campus-wide license. And if I'm to know more about a particular product, I'll simply click on that. In this case, let's select HDL Coder. What this would give me is a brief description of HDL Coder, what it is about, and then the getting started resources, which are especially helpful for new users, other aspects of HDL Coder, and then all the resources pertaining to HDL Coder. Resources such as functions or commands that you could use for HDL Coder, the technical articles, use case scenarios, trainings, examples, and videos and webinars. The same goes for other products also. You would have the brief description, getting started resources, and the full other resources. So that format is standard, and you could use this to know more about a product, or if you want to review the documentation for something. The next feature we have on this portal is the support page. So this has resources in terms of any assistance that you may require during the installation or after installation. So there is installation help for step-by-step instructions on how to install MATLAB, how to activate, how to reactivate your existing installation, and so on. And then there is documentation, the full documentation. Finally, MATLAB answers in this section. The MATLAB answers is our community forum where you could post your queries, and these queries are seen and addressed by other community members or Mathworks staff members itself, that is our colleagues. In case the issue is more complex in nature, you could always call us or you could create a support request as well. We would be also sharing our team's email address so that you could email us directly as well, be it any installation related issue or a technical issue. Next, we have the learning section, or rather a training, self-paced training section called as Learn to Use MATLAB in Simulink. This is open for all, any new users, any existing users, students, faculty members, researchers, and so on. So this particular section, you can go to Explore Courses and then select View My Courses. So either that, or you could also directly go to matlabacademy.mathworks.com and directly log in as well. What we see here is the getting started or the on-ramp courses. These are the basic courses for a new user. Each course might be undertaken in 1 hour or 2 hours. And these are the basic courses for those particular products such as MATLAB, Simulink, machine learning, deep learning, and so on. Those products or technologies, rather. Then we have some core MATLAB courses such as MATLAB fundamentals, MATLAB for data processing and visualization, MATLAB programming techniques. Now, after that, we have courses which are for that particular toolbox or that particular technology or topic. For example, here is one for computational mathematics or data science and so on. You could also look for all the courses under here. And at the end of each course, a course completion certificate would be issued, which is an official certificate from Mathworks. And this would be helping you from the career perspective as well. After that, we have the Teach with MATLAB and Simulink. Now, this is a dedicated section for faculty members and professors. This has resources such as MATLAB courseware, live editor, MATLAB grader, and so on. This can be especially helpful while you're incorporating MATLAB or any of our products into the courseware or curriculum. Few months ago, we also added the online teaching with MATLAB and Simulink resources and ideas, given the current situation where most of us are working from home or teaching or taking classes from home. That should be about the portal. And let's see if we have any questions on the portal side or any questions on the presentation as well. Again, participants, please feel free to unmute yourselves to ask the questions, or you could post the questions on the WebEx, I'm sorry, on the Teams chat window as well.
Sir, this is Simon from Max department.
Go
I
ahead,
have
sir.
one question. I have one question. Whether I can download the software in my laptop as well as my desktop in
Yes,
two
sir.
different. Yes, sir. Can I download it in using my same license, or
Yes.
only one time I can download?
Yes, sir. You can download and activate MATLAB on 2 different machines with different platforms, Windows, Mac, or Linux. We support all the 3 platforms. And yeah, each user associated with the individual license can download MATLAB on 2 different computers.
Thank you, sir.
Sure, sir. All right. Let's see if we have any other questions on the presentation side or the portal demonstration. Harish has also shared the portal link on the Teams chat window. So if any of you want to try associating with the license quickly now, you could do that, or you could also do it at the end of the presentation. Covering on the next topic, which I quickly wanted to cover was, or rather not deep dive into, because the topic itself is very vast. Let me bring it up here. There we go. So in terms of the features of 2020B, or what we have added in 2020B, then we would be sharing a link with you where we could specifically check what exactly changed in 2020B. In terms of improvement, you could say that we have had performance changes where the time that it used to take for certain functions has been shortened. So that has been improved. In terms of for other aspects, we have included more library functions supporting C, C++, and these kind of features or improvements have been made. As a brief list, I would like to share this with you all in the chat window so that you could review it later. And in case there are no questions now, then I would like to hand it over to Harish.
Yes, Jamal.
Thank you, sir, for this informative session. Next, I would like to call upon Mr. Harish Murthy. Yes, sir?
Yes, continue.
Yes,
right.
I would like to call upon Mr. Harish Murthy, who is an education customer success specialist and the point of contact between the institute and the Mathworks, to talk about the installation, the tools required, and the new features of MATLAB 2020p.
All right. Thank you again. Yeah, I'm still having some issues going ahead and sharing the screen. I'll ask Jamal to share the screen. Just give me a minute. Jamal?
Sure, Harish. You could pass on the
I have-
document and I'll share
Yes.
the screen.
Yes, Jamal, just a moment. I'm just sending you an email on the same.
In the meantime, while we get that set up, I would like to tell everyone that if you have any follow-up questions after this meeting, or if you have any queries or concerns or issues, please feel free to reach out to us. Even if it's a simple question or a simple query, we would be glad to assist. Do not hesitate to contact us for any manner of support.
Sir, can you talk about the career in Mathworks? Students who
I'm
are
sorry.
doing courses, can you
Right.
please talk about the career?
Right, definitely. So about that, I would Akhil, do you think that would be I mean, that would be a topic for you?
I'm sorry, Jamal. I was not able to get it properly.
Oh
Could you
yeah,
please repeat the question?
sure. So we are discussing about the career perspective. So specifically from the courses aspect, the trainings that we have on the MATLAB Academy.
Right, Jamal. Yes, I will be doing that. Thank you.
Great. Sure. So, sir, Akhil would be covering that part briefly. I think he'd be the best person to discuss about that. And yeah, let me go ahead and bring up Harish's presentation online. Give me a quick moment. All right, we have the presentation coming online in a minute.
Thank you, Jamal, for that. And sorry all for the delay. I'm having some technical issues in sharing the presentation, so Jamal is doing that for me. All right, and yeah, so this was the introduction slide, and Jamal, could you just move on to the next slide? Yeah, next slide, Jamal, as we have already introduced. All right, so this is the accounts team from Mathworks and from the Hindustan Institute of Technology and Science team. I'm sorry, I haven't, there's a different slide that has not been updated here. So that would be Simon, sir. So anyone having any issues or concerns, if you are having any difficulties in reaching out to us, you may always reach out to Simon, sir, and he would address it, and he would also uh, uh, redirect us to the same. All right. Jamal, could you just move on to the next slide? All right. Here. So the reason why we wanted to do this re-onboarding and portal demonstration is just to ensure that there is a focused streamlining on the installation and the deployment of the campus-wide license. And also, as Jamal mentioned earlier, to ensure that all the end users, that is the faculties and the students in the institute, are using the campus-wide license which the institute has purchased, and they can stop using if they have any pirated versions or trial license, because the institute has purchased a full license with additional features. And also to ensure all the potential users know how to access the MATLAB portal that has been created for the institute, and they can download the software by going to the portal. Next slide, Jamal. All right. Yeah. Simon, so you did have a question on if this can be installed on the personal computer. So I'm just going to address a couple of questions which Jamal might have missed, because Jamal has already covered most of the points. All right. And this campus-wide license includes all the faculties, research scholars, and the students in the institute. The installation of the software and the toolboxes can be done on both the institute-provided computer as well as personal computers. And faculties and students have the access to the software from anywhere. It can be home, classroom, or in case if they are working on a project in a different institute, they can also access it from anywhere. It is not only restricted to a classroom or a lab. And also, along with this campus-wide license, you would also be getting the MATLAB online and the MATLAB mobile, where this can be accessed through the browser and the mobile devices. All right. And we do have the online training courses, which Jamal showed earlier. So upon course completion, you would also be getting a course completion certificate, which can be shared on the LinkedIn profile, and that adds a value when you are looking for a job. And for the faculties, we do have the MATLAB grader, where you can go ahead and auto-grade the assignments, and students would be auto-graded. All right. And additional support is also provided on low-cost hardware projects like Arduino or Raspberry Pi. For more information on that, you may always reach out to Akhil, and Akhil and his team would be happy to help you out in the projects and complete them. Next slide, Jamal. All right. So this diagram here represents the engagement between the institute and the Mathworks team. So we would be working with Simon, sir, in order to ensure that the launch of this campus-wide license across the university is successful, and everyone is aware of this, and they are able to go ahead and use the MATLAB and the other features without any issues. All right. And also we have Akhil. Akhil and his team would be working with Simon sir and the other research scholars in the institute in terms of any technical consultation or curriculum development. And Akhil would be talking about that when he is presenting his slide. All right. Jamal, I guess most of them are covered now. So I guess Akhil can take over because you have already covered everything. Thank you all.
Thank you, sir, for this knowledgeable session. I would now like to take this opportunity to introduce our next speaker, Mr. Akhil Gopinath, who will be conducting the webinar. Mr. Akhil is an educational technical evangelist at Mathworks India. He works with students, faculties, and researchers to help them get the most of Mathworks products. He graduated with a master's in chemical engineering from IIT Madras in the year 2019. He specializes in statistical analysis and design of experiments, process modeling and simulation, optimization, parameters estimation, and artificial neural networks. He has publications in the field of optimization algorithm development and utilization of artificial neural networks in physical systems.
I request Mr. Akhil to share your screen.
Hello, Professor. Just give me 1 second. I'm trying to get the screen up.
Okay, sir.
I hope it is visible now.
Yes.
Thank you. Thank you for the kind words and good morning, everyone. And thank you for being here at early morning. I hope you had a great learning session with Jamal and Harish. So they have told you how to reach out and get your own versions of MATLAB and where you can get started. So we'll take a little bit of that at the end of the session as well. I'll walk you through where you can find this and where you can identify different material which would be useful in any application that you have. So for the major part of the session, I would be talking about the graph and network algorithms using MATLAB. So we'd be focusing on 3 areas specifically. One is why we actually study graph theory, how can we build and visualize them, and how we analyze these graphs. Then using this concepts or knowledge that we gain, we will see how real life applications are modeled using graph theory and its principles. And then we would talk about how or where we come into picture, right? So I think we can get started now. So I'll not go into the mathematics of graph theory, but let us define certain terms. So graph theory is basically simply put up a study of graphs. It's finding a relationship amongst the entities in a graph. So when we talk about entities, what are the entities in a graph, right? So there are 2 entities which we will be predominantly noting, that is vertices or edges. Vertices are basically the points that you see on a typical graph. For example, if you make a plot, right, there might be data points of the experiment that you did, and the line that you connect between 2 can be an edge, right? So in this case, the vertices actually define any component, a physical component, and edges will define how they are connected or how they are linked. Okay, a simple graph, visual representation of how these vertices, or we can also call them nodes, are connected to each other through these edges. Okay, and when we do not know how these edges arise or from where these edges are coming and to where these edges are going, that becomes an undirected graph. And when there is a direction associated with edges, it becomes a directed graph. So I'm sure that most of us know the fundamentals of graph theory. So I just wanted to just put up certain terms so that if there is anybody who do not know much about this, we can get started with that. Okay, so now just one of the questions that come into picture is, why do we have to take this particular topic as a prima focus, right? So graph theory is basically used everywhere that we see. Every application that we see has some sort of entity in it, right? Be it social media, where you yourself are the entity, and all the likings that you make, or all the suggestions that you get, or all the feed links that you get. For example, on a Facebook, you might be getting such certain posts, right? or in case of LinkedIn, you will be suggested with a lot of different people that you can connect to. So these are entities, and they are connected to, you are connected to those entities because of your previous interactions, previous behavioral change, behavior that you have mentioned, shown online. So that is a kind of relation that in realistically social media is also using to implement, giving you the best suggestions possible in terms of, let us say, maps, right? When you say Google Maps, or it tries to find out the shortest distance to travel for you. So basically, Google Map is also deploying one sort of graph theory analysis in this, where the location where you have to go and the different junctions may become the nodes or the point vertices that we are talking about, and the roads, the path that you have to travel, becomes the edges, right? And the objective over there is to find the shortest path, and that is a classical analysis that is that graph theory actually formalizes, right? Now, in terms of biology, it is not only about physical system, it's also about biological systems. And I specifically chose this image because in biological system, proteins play a big role. And in a lot of vaccine development, which is one of the buzzwords going around, graph theory plays a lot of important role into analyzing which factor or which component in a protein would be. Hello, am I audible?
Yes, sir. Yes, sir.
Yeah, I got some feedback, that's why.
Yeah,
Right.
okay.
Which component or a factor in a protein would be, binding with the medicine, and what factors should not be binding with medicine, and how it is capturing the disease causing cells, right? So these are a couple of things that graph theory properly identifies and helps the students and the researchers understand which parts of this particular protein can be removed, or which part of these proteins are useful, and which part of these proteins need to be covered. So that's a very important field. I'm not going to go in details of this because that may be out of interest for many of us, right? Because we come from various different departments. So we'll stick to generic examples on all cases. Now we understand that graph theory is actually quite widely used. So now let us see one of the practical examples. So this is one of our math worker. So this was a pretty interesting and exciting thing when I read about it. So they used graph theory to figure out, or predict when a breakup can occur. So I believe when I read this first in 2016, I was in the final year of my bachelor's, if I'm not wrong. And this was quite an interesting one for me, because I never thought that the graphs and analysis techniques that we apply, to a lot of different tools like biology and mapping and etc. can be used in this kind of analysis too. So this just gives you a broad idea that even emotional, connect can be at least up to a level predicted by, using graph theory and its analysis. So if you're interested, when I share this slide, you can just go to the blog and you can read more about this. It's really interesting though. So we have known a little bit about graph theory. I'm not going to spend much time on that. We'll be spending more time on applying that using MATLAB. Okay. So before we actually get into graphs theory or, anything on analysis, we have to start building the graphs, right? So how do we do that? So let's take 3 different examples and see how we can do this. First is foremost, which comes into my mind is, how to build a graph if I know all the vertices. Let us say I know A connects B, A connects C, or 1 connects 2, 1 connects 3. How do I do that in MATLAB? So let's jump right onto MATLAB. If anybody has MATLAB open right now, you can work with me. Or if you want to, you can try with me, or you can do this later also. I'll be sharing all the files and codes along with the presentation with you, so that you can replicate the same thing at your end and get started. So let me shift to MATLAB window. Let me reshare my screen. I believe I'm only sharing the presentation right now. So, I hope my screen is visible to everyone. Harish, Jamal,
Yes,
please
Akhil.
give
Yes,
me a heads
Akhil.
up.
Yeah.
Yes, yes.
Perfect. Thank you. Right. Now let us say if I have my question was if I have a list of edge graphs, right? So I already linked it to a small application that I created. So let me just open it up. It should be right up over here. You're right. So what I did is before going into MATLAB, if I'm not quite sure if everybody is aware of MATLAB, so let me just take a few minutes to explain what this would look like. So when you open MATLAB, you would be seeing a screen like this. So the fun part is there are 4 parts which we have to take care of, or which we have to know about, and rest of everything is quite intuitive. One is current folder, which shows you the current directory where all the files are. Why this is important is all the files which are in this directory can be used directly. You do not have for using this particular file, let's say visualize_search. I can just type its name and I can start using it. If I'm not in this directory and I try to use this file, it may throw up an error saying, hey, I'm not able to find where this particular file is. So current directory is something that you would be often referring to as working directory, current working directory. Okay. So this is just to hold and show which files are there in the current file path. That's it. Command window is another area where you would be using quite often. This is basically an executable environment where you can just write your logic. Let's say 1 plus 2. It can show me a 3, or let's say a is equal to 5 sine of pi by 4. Yes, pi is an inbuilt statement, so you can just say this. So this is where you can enter or input a single line of logic, and when you press enter key or return tab, it will actually execute that piece of code. Right? It's quite useful when you have to quickly do something. Let's say calculate a Taylor series or something of that sort. You can actually do it. Let me show you. Let's say if it's symbolic. I'm calling it a symbolic statement because I want to have an expanded form of Taylor series for, let's say, sine x. Sine of x. Now I want to use a Taylor series expansion for that. So I'll just say Taylor series of y. And it shows me a Taylor series truncated up to particular amount of order, right? So, yep, this is something that if you have to quickly do something, I just go to command window. Now we'll see why command window may not be quite useful on a longer run. And quite interestingly, if you have noticed on the right side, there is a workspace where all the different variables that I actually created are coming up. So if I don't create a variable and just execute it, it is automatically creating an answer variable and storing everything over there. You can see what is a value stored. If it is symbolic, that would mean it is expression that we are having. If it's a value, that would mean it's whatever value it contains. Additionally, you can find a lot many things by right clicking and just selecting which all things that you want. Usually class is something that I keep. So this gives you a whole idea of what files you can use, how to just check it out quickly, whatever commands that you want to work with, and where your variables are stored, right? Now, where is the fourth part, right? The fourth part is this ribbon that you see up on the top. So this ribbon gives you access to multiple tools and products that we have. So one of the key things is in this, as I mentioned, you have to execute every statement that you write, right? What about an algorithm that you write? Where do you use that? So that's where we have to write it as a script. So there are 2 forms of script. One is a regular script where you can write all your commands in one, let's say x is equal to 10, y is equal to 50, and so on. You write your algorithm, and at the end of the day, you can run it. And whatever results you want to show, it would be coming out in the command window or as a graphical plot, correct? Now, what if I have to, I have to see what is happening right next to me, right next to my code. And I also want to, export this in form of a Word document because I might be submitting a science project, or I might be submitting my final year project, right? So how do we do that? So another type of script that came up in 2018, if I'm not wrong, is Jamal, do correct me if I'm wrong. So live scripts. So live scripts is an interactive environment. So the difference between this script is when you run the script, everything runs in one go, and then you can get the results in the command window. But let's see what happens up over here. Let me just run this just for understanding's sake. So I'll just have to save this, and when I run this, okay, You can see X and Y are coming up on the command window. It is declared up in the workspace as well, right? Awesome. Now let me go to the live script. How I get to this live script is one thing that might be a question. One way to get to this live script is saying new script, new live script in the home tab. Other is just clicking on this and just going to live script, right? So when I click on the live script, it opens up a blank live script. One of the key things that you will be noticing over here is there is a horizontal bar and a gray area. Let's see what this is, right? Let's explore together. So if I write X is equal to 10 and Y is equal to 20. Now let me run this as I did before. One thing is I don't have to save this. Second, you can see the whatever I ran up over here, the result is coming up right on the next of it, right? Now let me say if I have to plot, let me declare another variable. A is equal to 1. Let me say 1, 2, 3, 10 maybe, or let's say 4 and 5. Let me create a vector quickly. The semicolon should suppress the output. So let me see what happens if I put a semicolon, and then B is equal to sine of A, or let's say A raised to 2. So let me do this, plot A comma B. So you can see the plot is coming right next to it immediately when I do this. Now what if I want to just have it below, right? So I can just go to view, I can just say output inline, and then I can see that, okay, after executing every line, it is showing the output right below it. So this is just one part of this. And if you have to interact with figure, for example, you just click on this figure and you can see there is a figure pane that come up. You can add all the things that you want. Let's say if I want to add a legend, I can just click on it and it will say, okay, a legend is coming up. If I want to edit the legend, I can just double click on that and say, hey, line. And the part is it will tell you how to update this if you want to, because I can just save this file and then it will show me, okay, there is an updated code that you can put up, and I'll just click on it and it will show the codes also. Now, one more thing that I can actually work with this is, let us say I just want to change this 2 to something which users can change. So I'll just select this 2, go to control, and I have multiple user interfaces. Let's say numerical slider. If I press on slider, let me just change the value to something maybe. Let's say the slider goes from 0 to 4. Perfect. With a step size of 1. Now what I can do is I can just move this around and you can see how the plot is changing, right? So in this way, if you want to, create an interactive application, you can do that right on your, script. If you want to check certain parameters, how they are affecting the, system, you can do this also. So this is quite widely used when, I have used this when I was presenting my thesis, final thesis, solution. And at the same time, I have seen faculties use it quite extensively when they have to teach something. And I've seen students use it like for learning the concepts that they see in the classroom. Sometimes we'll just talk about one small easy solution in the classroom because it is limited to that in the blackboard, right? But with this, you will be able to, just check it out and try it all out. So why I spend this much time on this is because we'll be using live scripts for the further examples that we are going to work with. And at the same time, I just wanted to introduce you to some things which are quite new if you have been using this for, before the live scripts come up. Additionally, one more thing that might be useful for engineering folks or in general, any person is, the task. Task is an interactive small application. So in 2020 B, you also have a task for optimization. So if you have a optimization problem, you can set it up interactively. So what interactively is happening over here is when I click on a task, it should show up a graphical user interface for me. So initially it will take a bit of time for me because I think Teams is eating up my memory a lot. So you can see I can have different, I just have to click on what type of optimization that I have to perform. If it is linear objective function is linear or quadratic or least squares, you can select on those. You can say if it is unconstrained or non-constrained, if it is bounded by somewhere, what type of solver you have to use. If it is, simplex method, Neldo-Mead simplex method, or let's say particle swarm optimization or a genetic algorithm, anything you can just choose from these lists. And at the same time, you can select if your objective function in some sort of file, you can do that. And you can display whatever display that you want to put up, you can put it up over here, and you can also display your solver options. So this becomes an interactive way of solving optimization problems if you are not much into coding. Right. So before I move ahead to the actual demos, any questions? I'll just pop into Teams. Any questions in general? Okay. Okay. No questions yet, I believe. So let's jump into our actual problem, how to create graphs. And sorry if anybody already knew all this. Yep, it's a bit slow on that side. So let's get started to the fun part, right? So let me clear the screen and everything else. So clear basically removes everything from the workspace. CLC will clean this. So let me just go back to the thing that we were trying to use. So you can see this is a live script which I created, and you can see how I have formatted the comments over here. Like I put it as a text. This will not be executed, right? This is just comments. So yep. At the end, I will show you how we can export this as a a PDF or Word document. Now I'm saying that okay, these are my vertices which are sources where the edges would start from, and these are the end points, end vertices of this. So basically what this means is one will connect to 1 will connect to 4, 1 will connect to 8, 2 will connect to 3, 2 will connect to 7. So this becomes very tedious, right? For example, in a real life situation, this might be, let's say, for an Amazon delivery agent. Amazon delivery agent has to go to let's say sector 1, sector 2, sector 3, city 1, city 2, city 3, block 1, apartment 2. So that will become a very tedious thing to put it in numbers. So we have to graphically see how to create this, right? So one is creating a graph. So in MATLAB, all you have to do is just say graph, source, and target. And you just have to put the coordinates if you know the coordinates of the vertices, and that's it. It will create a graph. Now let's see how this graph would look like. So you can see before we go to that, you can see it is automatically defining that there are 8 nodes in this graph, and there are around 12 edges in this graph. Okay, so let's see how this graph would look like. So you can see this graph is of a cube which is connected as given in this table, right? It's very straight away, very simple application of building a graph, right? Now the question comes up, what if it is a directed graph, right? What if there is a direction too? One way to do is to just put die in front of it, which is die graph, which pretty much creates a directional graph. If you know the directions, it will automatically take the directions from source to target if you do not specify anything. So it's quite easy, right? It is just like whatever you wanted it to do, you are just writing it down in as a function. That's it. And direct plotting would plot the graph for you. So this is basic graph building, and then we'll move around to one more thing that we have to work with. So this was when we have an edge list. We saw how live scripts can work up. We saw how we can just create a list of entities and create a graph out of it. So slowly we'll go to complicated systems. Okay, now let us say when we have to construct graphs with tables. Perfect. So now let's see. This is going to be a diagram. So in this, we have taken 2 sections. We are saying, okay, this is the source, this is the target. This will give us the direction of the graph. Then one of the interesting things that we have to work with is weights of these edges. Weights give something known as some sort of importance to the particular edge. Okay. And we are just saying, okay, these edges can be coded in this particular, with these particular variables. We are saying, okay, these are the names given to the edges. Okay. And we are creating a table. Usually what happens is you get a data in form of a table, correct? in here we are creating a table, but usually you get this table right directly and you have to use this table to create a graph. So now assuming that we were given data in form of edge table, how do we create a digraph out of it? So we are just naming the vertices to be USA, Britain, Dutch, I think, and France. So let me just create another node table. Node table will give you, okay, country code is 1, then its name is USA. If country code is 44, its name is GBR. If it is 49, it is DEU, and so on. So you have two tables now, right? You have a table which has node details, weight, and the code. Then you have another table which says which code corresponds to which part. Okay. Now, how do I create this? So that's same as we did before. You just have to call digraph. Instead of having target and source in this case, source and target in this case, you have edge table which contains these details, and you have node table which contains the node information, and you just plot it. So let me see how it looks like. So you can see how it looks like now, right? So right now, if you can see in this plot command, I have put up additional functionalities or additional flags. One is I'm saying what is the node label. Okay, I'm saying node label is country, and in here you can see the country is code for us, right? So what if I change it to name and then rerun it? Now you can see instead of codes, it is showing nodes as country names. Correct? Because graph theory is predominantly based on visualizing the graph and then analyzing that graph, right? This is a visual analysis of the structured data that we get. So this is very important when it comes to showing your graph in a readable format. Okay, great. Now instead of codes, you can show weights, or you can show any values that is in the table of edges. So this is how you can show labeled digraph out of table data or tabular data. Okay, so these are two basic examples of how to build graphs when you have edge data or when you have table data. So any questions till now? Because I believe sir mentioned that plotting is, or construction of graphs is one of the key challenges that we had before, because people had to write their own coding for this. Any questions?
Yeah, hello, sir.
Yes, Simon, sir.
Yeah, no, sir. Sir, actually, I have one question actually.
Oh, yes, please go ahead.
Now only you told me that Amazon they are going to somewhere for delivery purpose or something. So
Yes.
we are converting to graph and all these things. So can you please explain it again?
Sure, perfect. Okay, that's a really good question. So let's take a new live script to explain what I meant by that. Okay.
Okay.
So let us say this is delivery boys location. Okay. So I'm calling the number. I'm giving numbers to each of the buildings or cities he has to go to. Okay. So let us say delivery boy is going first to the first building, then going from the first building, he would be going to somewhere, right? So let me create this in form of a, okay. Let's say from, and then I'll create one more delivery boys 2. Okay. So let's say 1 or 0. 0 is his warehouse. Now let us create simultaneously. So let's work. So from 0 he is going to 1. Okay. Now from 1 he is right now at 1, right? Now from 1 he is going to, let's say, 5th home, because maybe he just wanted to go 5th. So now from 5th he is going to house number 2. Okay, perfect. Now from 2, let us say he is going to house number 4. So we'll say 4. Okay, and from 4 he is going to house number 3. Okay, so he's 3, and then ideally he should go to warehouse, but then he figured out, okay, he forgot something to give at house number 1.
Okay.
Then he went to 1, he goes to 1, then from 1 he goes to 0. Okay, so in form of his to and fro, where he started from and where he ended up, we created a set of vectors. This information as in like this will not make much sense to us, right? Now let's make a directed graph, because direction is very important in this, right? From where he went and to where he went to. So I say digraph. It is just digraph. So I would say delivery boy, delivery boys from to delivery boys to, and it oh right, I'm sorry, this should be starting from 1 because it is indexes, right? And MATLAB starts from 1, sorry, that's why. So let's say it is 1, he went to, yes, okay, no problem. So what I can do is I can just add 1 to this, right? The best part about MATLAB is you can do things in a matrix format. So what happens is if I add just 1, everything becomes from 1 to plus 1, right? So now I have created this diagram, but I have to save it in some sort of variable to plot it, right? So I save it to G. Now what I'm going to do is I'm going to plot this. Plot G. Now when we see this, this makes much more sense to me, right? Hello.
Yeah.
Right. This makes much more sense to me because I can see, okay, he is going from one place to another and he's coming back and all that sort of things, right? Right. The whole idea behind, me plotting this or showing this is when you have data which is unstructured in form of, instructions or, random data that a person might be choosing to travel on. Many companies like Amazon, let's say Domino's or Uber, they have inherently used this algorithms, these similar to these algorithms, to ensure that they do not spend more than required time in traveling. Okay, so the productive time is only when they are interacting with the customer or sending and getting things done, right? So when your delivery boy says, hey, I went there, I went there, I went there, in form of a text, it would be very difficult for us to analyze what is happening. But as we saw, if we create some graph like this, then I know exactly, okay, this is the path he took. Now I can do much more fine tuning in this and figure out, okay, which would have been the best possible path he could have taken. Right? So that comes in an analysis path. We will do that analysis also, just to give you a perspective of why this is important. Now, once we have analyzed, okay, this is the path that should be taken. If we tell the delivery boy, okay, you should take this path, or if you're managing an industry where lot of raw materials need to be procured, then we will look for suppliers nearest to us, or suppliers in a different format, so that if a supplier is supplying to one other company, then our transportation cost should be minimum, right? So these are like real life applications, very simple applications, but very important applications of why we are building these. I hope that answered your question.
Sir, can I learn all those things from YouTube or some other places?
You want to learn, okay, for understanding the fundamentals of this, right? The mathematics, this is just directly plotting everything, right? So you might be wondering, what is the mathematics behind that, if I'm not wrong?
Yeah.
Right? Yes, I can show it to you right away so that everybody is on the same line. So we have we have a set of lectures by a professor in Massachusetts Institute of Technology at Mathworks website itself. So this is one of the examples or one of the classes where they are, telling you just how exactly this is done. So let me just go to, if you're ever in doubt, just go to mathworks.com. Even if it is not related to MATLAB, let us say it is related to mathematics in this case, right? What is the mathematics behind graph theories? So what I do is I'll just say graph theory. I'm just searching it up over here, and I'm trying to figure out if there is something of, let's say, videos or answers or something of that sort. The videos, it will show, yes, here is a video. So you can see this video is by Professor Gilbert. So he will, this video is completely on mathematics. It does not tell you about MATLAB or anything. This tells you about mathematics behind graph theory, and what is the importance of it, and you have a whole series of such videos up here.
Okay.
You get me? So this might be one of the places where you can get started on the background knowledge of what things are, if you're interested in mathematics, right? Mathematical background of this in the first place, and if you're not aware of that, you can start from here, because up here you can do two ways. One is you can write this logic in mathematics using MATLAB and then do everything again, but we already have certain functionalities for you so that you can focus on application perspective, right? I hope that answers and clarifies your questions.
Yes, sir.
Thank you. That was a great question. I hope many people found it useful. Great. So let me go back to the next one. So we saw how we can construct with tables, right? Now let's go for plotting and customization. So this is very important part, because graphs are. Yes, sir.
I have one question. While drawing the graph, is there any restriction for the number of nodes? And that's one first question. Second question, how to upload it in the Word file after drawing the graph using MATLAB? How to upload it in a Word document? Because for writing research papers, we may need to draw the graph, complicated graphs using MATLAB. How to cut and paste? Is it possible to? What is the procedure for that? Can you please explain?
I totally understand where that question is coming from, sir, because I personally had this challenge when I was publishing papers, because I was using MATLAB and I was like copy pasting things, first importing everything on a JPEG file and then pasting it on the Word document. A very complicated workflow, right? So I'll show you that. And secondary, sir, to the first part of your question, the number of nodes limitation. So the limitation is only the memory in your laptop or computer. Hello?
Yes, sir.
Yep, it is only up to the memory that you have. And in case if you have, let us say, in case if you have data in terms of a node table, which is pretty much possible in industries, right? So we have something known as tall arrays. I'll just show what tall arrays are. So tall arrays will help you work with data which are out of memory also. If you're ever in doubt of anything, just write whatever is your doubt and just add MATLAB or Mathworks at the end, and you will, more often than not, you will find out a documentation page which refers to the same topic. So this gives you a ability to process this big data, which is one of the keywords that are running around, right? Big data, without actually losing out on the computer's memory. It will take your array or data in pieces and chunks, so that at a time your memory is not completely full and your system does not hang down and it is not responsive and all that problems. So that is one way. So limit is, sir, as much data that you have, you will be able to plot a graph for. But the catch up over here becomes how easy or difficult will it become to visualize, right? Because when you have a lot of data, it may become very clustered and it may become very unwieldy or unsoothing to eyes to look at, right? So it may lose the effect that we are trying to get it to. So we do have certain functionalities to reduce that also. We will see how we can do that too. Sir, I hope I answered your question. The part one of the question.
Yes, sir. Yes, sir. Second question, sir.
Yes, sir. For second question, let me get to this particular example and then I'll show how to do that for that particular example itself.
Okay, sir. Okay.
Right.
Please go
Okay.
ahead.
So let me just go to graphing and plotting. So up over here, what I'm gonna plot is a Buckminster's fullerenes. I believe we all have been very much, horrored by this in our chemistry when we started chemistry in sixth when we were learning the carbon, right? So there was a football-like structure with all sort of carbons, and we used to figure out, okay, how this look like? I mean, like in reality, they would say it looks like a football, but it is also a graph, right? Because every carbon atom would become a vertex, and every bond it will make with other carbon atom will become what? It will become a edge, right? So you see how this graph, simple graph logic is applicable to multitude of fields, right? Now we are talking about chemistry without actually understanding what is the background of it. We are just talking in terms of vertices and uh, edges, right? So in this, I wrote a small function which is available to everybody in your MATLAB Bucky. You don't need to write this. This gives you a set of coordinates for creating Buckminster's fullerenes. So let me just remove this. I'm just commenting this out. The reason being, I want to show what it looks like when I just use plot command, right? When I just use plot command, this becomes a 2D graph, right? One of the questions which was posed when I was doing this once before was, okay, this is very good, but in real life, this is a 3D structure. And the data that I have is also in 3D. So why is it only showing me 2D? Right. So how do I render this in 3D? So plot command inherently starts with a 2D, but you can change the layout by forcing it to go in 3D. So only what you have to add is you have to say, hey, layout force 3 and go in 3D. That's it. When I do this, you can see now it is rendering in 3D because it already has data and information from the node points and edges. It will automatically space it around, right? So now you can interact with this. So you can, probably zoom it in and then, pan it around maybe. So you can do all the interaction up over here. When you found that, okay, you have found a very good view for this particular thing, you can just, update this code because you can see automatically the code is being generated for you so that this particular view is maintained. Okay. Now this is simple part. Now, what if I have to, because everything is blue, what if I have to change certain nodes color, right? So what I can do is I can change the entire node's color by saying, okay, color is red, node color is red. So now what happens? P, okay, now one question that come up is what is P? So what I'm saying is whatever I'm plotting, I'm saving it in a variable so that I can, use it again and again. So in P, we have an option known as node color. I'm saying, okay, change the color to red. So in this node color has come to red. Now, one of the questions that I always get is, okay, I don't want to do this by coding. What can I do alternatively? So what you can do is, you can just open it up as a figure. There is this button, right? You just click on that. It pops up another figure window for you. Now what you can do is you can just say tools or property editors. So when you go to tools, you get so many options up over here. So I'm just restoring the view so that I don't mess up anything. I usually do edit plot like this. Then I click on something that I want to edit for. It opens up property inspector for me. In the property inspector, I can see, okay, this is the node C data. So what I can just put up over here is, let's say I say it is red. That's it. Oh, sorry, it will take up a vector in this format, right? So red is what? Red is RGB format. It is 100, right? I think that is the correct. Oh, right. I'm sorry. Node color is up here. My mistake happens with me all the time, I guess. So, right, I understand. Here we can change the node color in complete sense. You can see all the node colors are now changed to red. Now, one more point that I missed out when I was just looking at this, I forgot that I was doing the wrong thing, which is when you click on a node, Node C data is when you define color for all the points that you have in this, section. So if you have to give independent color or a gradient of color to these nodes, you can use node C data property. We will see that also in the further slides. So let me just go back to this. So right now we have changed color to red, and we saw how the color can be formed to red in an interactive window if you want. Now let us say if I want to increase the width of this line, because I feel like, okay, these lines are pretty small, so I can just say P line width. And now the line width has become 5. Now I have to see what P is, right? So I have to update plot or show here. Now what I can do is I can just go up and say, this is showing that line width is 0.5. So let me say line width is 2. Now you can see the line width have grown up, right? Perfect. Okay, great. I did not run this, so it will not come up like that. Now the point is, let us say I have, L-shaped membrane which is coming up like this. So I have created a logic to create this. Now the point is there might be self loops, right? Self loops means 30 is connected to 30 back again. So if I don't omit self loops, let me just run this and then plot this. So you can see there are self loops in here, right? These small loops. I'll just zoom it in. When an edge is connected to the same vertex, right, that becomes a self loop. And this is not something that is intriguing or interesting to us in this current scenario. So if you want to omit this while plotting, what you can do is when you say graph, you can just say omit self loops, and it will omit these self loops. It will understand which edges are connected to the same node, and then you can just simply plot it. All right, I have to run this, right? Then when I simply plot it, it actually omits the self loop. Now I have forced it to be a 3D version of this. Now when we have to put it as a gradient color. So this is one of the key things that I have observed. Sometimes what happens is gradient is based on the weights of these edges. Weights means how important this particular connection would be. So that depends on the use case. For example, if it is in terms of the question that was asked before, in terms of Amazon delivery boy, the weight might be given by Amazon to a big institution. For example, if there is a delivery which is of let's say 2 lakhs worth of a laptop, so that becomes very important, right? So that becomes a priority one task because they don't want to lose that equipment or lose that package anywhere. So they may want to color that particular node in their system as a red color. So when that comes up, you can use the C data to use that. So in here, the C data is based on the degree of the node. Degree means how many other nodes are other edges are connected to the node. Because this is not a directed data or directed graph, every node will become, every edge or every line that is coming out from the point will be counted as 1. So in 32, it is connected with 3, right? It is connected to 31, it is connected to 33, it is connected to 42. But in case of 42, it is connected to 4 other points, right? Which is 32, 41, 43, and if I'm not wrong, 52. Great. So you can change the colors of different sections of node, or you can give separate nodes to every, every node, separate color to every node using the C data. So it may sound a bit complex in the first place because we are not doing it right away, right? So when you try this out, you will figure out that this is quite straightforward. Now I can do this. Yes, there is a question. I'm sorry.
Yes, sir. This is Rohini, research scholar, sir. Sir, from this node, which is the most weighted vector can we find?
I'm sorry, from this node?
Which is the most weighted vector can we find, sir?
Right. So in this case, in this node, all the yellows would be the most weighted one in terms of degree, right?
Yes, sir.
So it has to be defined. I mean, like if you're talking about centrality, then that would become all the 4 points, right?
Yes, sir. Like this one.
Right. No problem. So now I can do the similar thing in terms of, width by weight as you were mentioning, right? We wanted to find the weights. So,
yeah, weights and also which one is the shortest path, like that
yes.
also it will
Right.
be good.
We would do the analysis in the coming section.
Okay, sir.
Right. So I took out time to ensure that we go through all of these one by one.
Okay, sir. Sure, sir.
Right. Great. So let me do this. I think we are running a bit below behind time. So let me just go to edges and weight. So
Okay,
G is the graph that we created. Edges is the weights we require for, right? Now when I run this, you can see this is the weight that is coming up. So now the question would be why this weight would be, right? Like this. Hello.
Yes, sir.
Right. That is because by default we have defined that all these weights are to be 1 actually, not -1, 1.
1.
Right. So they are all same. Now if we define the weights in terms of, let's say, their the number of nodes they're connected to, degrees, their degrees, right?
Yes,
or
sir.
let us say if you're defining weights in terms of centrality, then we have an algorithm by which we can change the weights, right? That's exactly what we are doing up over here.
Yes, sir.
Okay. So
Yes,
we are
sir.
changing the weights with respect to our algorithm up over here. Okay.
Okay,
And
sir.
after that, what we are trying to do is if these based on these weights, we are trying to change the line width.
Okay.
So once we can see the line width, you can see, okay, the line width is changing significantly for some other things based on the edge weights.
Okay,
right? So weights are something that you have to define in terms of, some sort of algorithm at the back end.
Okay. So now you applied algorithm in this?
I just put weight to be this.
Okay.
Okay.
Okay, sir.
Awesome. I'm just using a randomized number to, just put weights to all the edges as a random number, random integer.
Okay.
Between 10 to 250. Now I'm just saying, okay, some of the lower weights are like this, and then I'm just putting up line width. Okay. So these are randomly put up weights.
Okay.
Then I'm using some sort of algorithm to change it.
Okay, sir.
Okay.
Okay, sir.
Right. So in usual cases, the weights are gonna be like, for example, I'll take example of Amazon delivery boy again and again. Sorry for that. In that case, the weight would be the distance and the and another value which would be linked to that weight is the let's say worth of the product that the customer the delivery boy has to deliver, right? So for example, if he has to go, let's say 2 kilometers away to deliver a laptop of 2 lakhs, and he has to go to 5 kilometer away where he has to deliver a notebook of, let's say, 500 rupees, right? So the priority or the weight should be in a format that should give higher priority to the laptop in this case. And in case if it is a 500 rupee notebook in 2 kilometer and 500 rupee notebook in 5 kilometer, it should be giving priority to the 5 kilometer, because then he can come back in an easy format, right? The shortest path algorithms would come into picture. So weights are something that would be defined by the question in hand or the problem in hand. Okay. I hope that answers the query.
Sir. Yes, you are answered, sir.
Thank you. So let's move ahead quickly because I think we will be losing time otherwise on a, So we are just tracking this subgraph because I just want to focus on graphs in this area. So I can just say, okay, subgraph of this graph G where nodes are between this and this. Sorry, 1 to 31 and 36 to 41. Okay. So that is a subgraph that I'm getting. Now I can label these nodes and edges with respect to saying, okay, if the L widths are greater than 6, then label them as large nodes or large edges. Right, in this case it is edge, so I'm saying, okay, whatever is greater than 6 in size, these are large. Now I can say shortest path, right? This is something that we'll talk about in detail, but right now let us say shortest path. So when I use the shortest path command in this small graph that I already subgraph that I have created, right? H is the subgraph. I'm finding the shortest path between the nodes 11 and 37. Oh, I'm sorry. So 11 and 37. So it is saying the path which it should follow to reach 37, and the shortest path is from 11 go to 12, then 17, then 18, then 23, and so on. And you can see we can highlight this path using the highlight command. Okay, so you can see how it is highlighting that for this, right? So this might be quite useful in any scenario where you have to optimize the path traveled from one node to another. So in this one catch is we are not putting any constraints on this, right? We are not saying, okay, you cannot go to 23 or you cannot go to 24. We are saying, okay, you can go to anywhere, but reach there in the shortest time. Other way around is also possible. Okay. Now these are all, different methods by which we can display graphs in a different manner. Okay. Now the point is, if I have to find the shortest path where the weights are not mattering, because sometimes or most of the times we will be considering weights in this case. So if I change the weights, you can see how the path is different. The path is now taking a rectangular kind of edge path, right? A perpendicular path from here to here and then here to here. Earlier what we were seeing, when it was considering weight, it was trying to maximize the number of weights that it was going through, right? Great. So I believe that this will give you an idea of when you are plotting graphs more than 100 nodes for visual scale. I have written all these information for you, information in this example. So maybe you can just go through this if you are dealing with even millions of nodes. Perfect. So now this brings us on the end of this visualization section, building and visualization. So any questions before I jump into the next section, because these are going to be taking some time, right?
Yes, sir. I have one question.
Yes, sir.
And while finding the shortest path, is it possible to put arrow in the edge to tell the direction?
It is perfectly possible, sir. It is perfectly possible in terms of a diagraph.
No, diagraph, we will put the direction for all the edges, but I am interested to put an arrow mark for particular path. So is it possible to edit some edges with direction?
Sir, off the bat, I'm not sure if we can do that, but I can get back to you on this. Okay. Because personally, I have not worked with the shortest path algorithms.
Okay,
right?
Sir,
so I usually work with diagraphs. So diagraphs already have the arrows for me. So when I highlight them, the arrows are coming up. So I've never come across with the alternate of that, right? But I'm pretty sure there is some functionality which we can utilize for that. Is it okay if I come back, get back to you on this later?
Yes, sir. Yes, sir. Yes, sir.
Perfect. Thank you, sir. So let's go to analysis of graph. Now we already saw how how the shortest path would be like. So let's talk about centrality, because we had a question regarding, okay, what is gonna be what is the importance of weights? How am I going to determine the weights? And if that is the case, which node is most important, right? So let's talk about centrality in that case. Right. So I'm taking a very realistic example. Let us say there are 6 websites. Okay. These are 6 fictitious websites. These are not real websites, to the best of my knowledge. So I have numbered websites with respect to 1 to 6. So website 1 would be alpha, 2 would be beta, and so on. And I have listed out how they are, linked to each other. There might be hyperlinks in website alpha to connect to website beta and so on, right? Now I create a diagram for this. It looks like this. Okay. Perfect. Now when I have the diagram for this, now I have to find out which of these websites is actually quite important, right? So that is something known as pager rank, right? I want to figure out which of these pages are quite useful. For example, if I am an advertising company, I want to advertise on a web page which is of a higher, a higher traffic in the sense number of people coming to that page should be more. Correct? So this is a very fictitious one right now. We are just going to see how we can do that. So there is something known as centrality. Centrality works inbuilt with respect to PageRank algorithm. So when we do this, what it is doing is it is only checking out how many links are, showing that, okay, there is a Gamma website, and how many links Gamma website or each website is linked to. For example, in this case, you can see Zeta is not showing any other web page link, right? There is only one incoming edge to this Zeta. Similarly, for Gamma, we see Gamma, there is no web page which comes to Gamma, but every Gamma is linked to 4 other web page, right? So you may figure out, okay, Gamma is actually quite good for me. Why don't I go with Gamma? So we'll see why it is not actually a good one. So in terms of alpha, we can see alpha is having 2 connections which is coming to alpha and 2 connections which is going from alpha. Okay. In delta, we have 2 connections coming to delta and 1 connection going from delta. So how do I figure out which web page is actually the correct web page for me to put up my advertisement on? So I check the centrality, and I can see in terms of centrality scores with respect to PageRank algorithm, which is dependent on how many links are coming to the website and how many links are going away from website. So in terms of that, it tells me that the best page to put my advertisement would be alpha, because alpha has maximum traffic. Okay. Because if it was degree, in terms of degree, total degree, in and out degree, alpha has 4, gamma has 4. So I would be considering alpha and gamma to have same score. But in this case, you can see gamma has one of the lowest scores, right? Except for zeta. So this gives me an idea based on graph theory, where exactly should I put my advertisement, or which web page should I put my advertisement on? I hope this makes sense. So I'm just changing the node page rank with respect to whatever page ranks we calculated. And I'm calculating, different hubs and authorities. These are certain terminologies that computer science engineers would be quite interested, or the web page developers would be quite interested. Hubs means how many websites is it connected to. So it would be only, like, for example, let's take Mathworks as an example. So in this page, you can see it is connected to all these web pages, right? Documentation, example, functions, and a lot of other web pages might be connected to this particular page also. So that makes this an authority. So I'm not going to go into details of this because this might become confusing on a initial basis. So let's just say it is like amount of gifts that you are receiving and the amount of gifts that you are giving to other person. So hubs is amount of gifts that you give to other person, and authority is amount of gift that you get. Okay, let's talk in terms of that. Now for the second part of this system, there is something known as closeness and betweenness in terms of Minnesota roads. So this is a real life example which Minnesota Road Development Authority wanted to work on with. So we just took a very small portion of what it might be like. So I'm just gonna load the XY data of the Minnesota coordinates of Minnesota roads. Okay, Minnesota is in USA. Right, using find edge, I'm trying to convert these coordinates into source and targets, and get the weights in terms of distance between two nodes. Okay, perfect. Now I'm going to plot this. Now I can see this is the Minnesota road plot. All the dots would be the junctions where the roads are coming up, and all the edges are the roads. Okay, now I want to find the centrality so as to figure out which roads are actually quite linked to other roads, or which junctions are actually quite linked to other junctions. and then use that data to change the color of my map. So what I can see is the roads in this area, red area, are linked to other nodes quite a lot. So they don't need any more roads probably. But the areas which are on the bluer side, they would need much more roads to connect them, right? So in this way, they can figure out, okay, which areas do we need to expand more in terms of road coverage or rail coverage or whichever feature they are trying to figure out for. So I hope this gives you an idea of where centrality becomes important and how we can display important data using that. Now, one of the thing is closeness, right? Closeness will tell me how congested a particular node is. So if a lot of nodes are, just clustered together, that would increase the closeness centrality, right? So you can see over here, we are showing that, okay, these nodes are like clustered together and the closeness centrality is maximum for these areas. Okay. So you get all, and betweenness is basically telling me which of the nodes are most connected with or most linked to other nodes. Which node leads to, a lot of other nodes. So in this, we are seeing betweenness, and the cost is matched as the weight of the edge or the distance between all of those nodes. Okay. And you can just color map it too. And you can see these roads which are colored as red are the roads which are connected maximum. So these might be highways, for example. So in this way, without even knowing what these roads are, you can actually take a educated guess that, okay, these might be the highways which are going to different parts of the Minnesota area. I hope this makes sense and this is clear. Any questions on this part? No. Okay.
Yes, sir, go ahead.
Thank you. So let me quickly go to simplify graph. So in this, what I will be talking about is how we can simplify a graph. Sometimes graphs can be very complicated, right? So I'm just going to run this entire section because it's going to be very difficult for me to, cover it up on time. So let me just tell you what this is all about. So this is about, different travel modes between New York and Boston, and what is the time required to travel and what is the cost required to travel. And it contains not only from New York to Boston, but Boston to Washington and other cities also. So what we are doing now is we are just, plotting this particular section. We see this is how I have created the plot. Now I have to figure out, I have to reduce this, simplify this in terms of, let us say, cost or time. So in terms of time, if I simplify this, I can say, okay, it is suggesting me to go from all these places to each other using air travel. Now, if it is, let's say, cost, I can just say simplify the graph G and in terms of cost. So in terms of cost, it is telling me that from New York to Washington, the least cost that I have to travel with is 425, and from Boston to this is 575, and it is 520. Now let's say if there were more nodes, we can just sum it up and see which one is going to be more, right? So in here, traveling from Washington DC to Boston is the costliest one. So this is quite useful for people who are running a transportation business. They will know how much value or money they can actually, gain in a particular route. So they can set it up for that route as a priority, right? If somebody comes to say, hey, I want to travel from Washington DC to New York, and at the same time somebody comes up and say, hey, I want to travel from Washington DC to Boston. Using this graph, he will, the travel agent would be able to say, hey, I will not be able to go to New York, but I can go to Boston, right? Because he's getting more money out of there. So I hope that makes sense. This is a very idealistic situation that I mentioned right now. Great. That's one of the ways you can simplify the graph. Now, shortest path, I wanted to take it as, a section itself, because shortest path is one of the most important things that we take up. So I was just making this random shape, which is connected by a lot of nodes and sections, right? Now I want to find the shortest path in this from node 6 to node 8, let us say, because this is a complicated section. And again, we just highlight that particular path and we can use the unweighted path. Luckily, we did this before only. So I just wanted to highlight this particular section in different because there might be multiple paths. In this way, in this one difference that I wanted to show is I wanted to show what happens if I'm taking weighted path and what happens if I'm taking unweighted path on the same path, on the same figure, right? So what I did is I just took this plot P, highlighted it over there, and then on the same plot P, I did a highlight. So in this way, what I wanted to show is there is a functionality wherein you can highlight paths or the shortest paths or make changes to the same plot over and over again by using this variable. That is why we declared this variable. Okay. So yep, any question on analysis of graphs part? We do have multitude of analysis techniques. I just did not have the time to show everything. So I will just show you where you can find more. So this is graph and networking algorithms in using MATLAB. Over here you can see there is entire section on analyze structure. So more than that, you can say if it is isomorphic, it is morphism, if it is multigraph, it is directed acyclic graph, right? So a lot of other condensation of graphs is also there. So these are all things that you can explore. They all have examples inbuilt. For example, let us come back to condensed graphs in this. So in terms of condensation, you can see there is an example given up over here of multigraphs and then, you know, condensing it into strongly connected points. So all these functionalities can also be explored by you later on. So now let us go to a real life application of this. I'm not quite sure if I'll be able to take up to. Sir, is it okay if I extend it a little bit, sir? If I go beyond time a little bit?
Yes, yes, sir. You can take another half an hour.
Thank you, sir. So one of the key examples that I wanted to take, I took these three examples because one is related to computer science team or even any person right now. You know, a startup is one of the key areas that everybody is working on. And usually the startup has a web page. And in order for us to be on top in terms of Google or other search engines, right? When somebody searches, your rank is computed by these search engines and then only they show you in a priority list. So this is quite important for us to understand what is page rank in that sense. So I'll just go to page rank algorithm in this one. So let me just go to page rank. So in this we are defining. Last time we were just randomly taking up some weights and just saying, okay, the weights is going to be like this, right? So this is actually the page rank algorithm that comes up. Okay, where R is a score and every detail is given up over here. You can go through the details of what these parameters are in the later time. Okay, now we are taking out the sample that we showed already. We are just focusing that again. But this is a page rank with 6 examples that we saw already, right? So this is not something that we are going to work with. We are going to work with page rank of websites on mathworks.com, a real life example. Now what I did is I took hundreds of web pages which is available on mathworks.com just to find out what is the page rank of those. Okay, so there are 100 unique web pages in this and I want to see how they are connected to each other. So this pi a would create a sparse matrix. Sparse matrix is, you know, if there is a element, it is good. If it is there is no element, it will just skip that, put a white space on there. Okay, so you can see, okay, web pages of these web pages have a lot of connections up over here. These are some values up over here. Pretty honestly, we cannot make sense what it is by looking at the sparse matrix, right? So we come into a different sort of graphs. We make a diagraph of it, right? Diagraph is directed graph. Now you can see how complicated this diagraph has become, right? Couple of things that we have to see up over here is there are self loops in this graph. There are various other interconnected loops up over here. There are clusters of different web pages, right? You can cluster this out. Let's say this is a multi-level graph. So this graph is connected to this big chunk of graph, but independently it also has a cluster of connections up over here. So this is how a real life web page link would look like, right? And you can see there are so many. This is just only 100 nodes right now, and it has become so complicated to visualize, right? So what we will do now is we would just find the centrality and page rank using internal algorithms. The algorithm is already mentioned up there, right? We want to see what is the in degree, out degree, and everything. So if I just remove the semicolon, we can see it gives me a table of whatever the degrees are. So it is stored in the node in degree and node out degree. Now what I want to do is I want to view the top 25 links. So what I can see up over here is these are the top 25 web pages in terms of page rank. The best page or best connected page is mathworks.com, which makes sense, which is the home page, right? We saw that whenever we go to mathworks.com, we can see it links to every single page in Mathworks web page, right? So many links up over here. Now, other web pages which are more important are independent country web pages. For example, Chinese or Canadian, Japanese, Korean, UK, and others are some which are related to a lot of privacy policies and other things. Okay, great. Now once we know that, let us plot subgraph of it where the score is greater than 0.5, because I don't need any score which is less than 0.5. So now you can see my graph has become a bit more clearer. Okay, because I have made these nodes in a different color. I hope that makes sense. And I have taken a subgraph of it. Right? Now I have very less number of nodes, but the connections are tremendous, right? So this is the way where how I can give an example. Google works in a similar direction. Google ranks the pages when somebody searches for something. Let us say if I search for let's say Apple, it will rank. It will see, okay, this is the network which is linked by a lot of other web pages, and this is the web page which is linking to other web pages. There is a lot of traffic, lot of other parameters are also taken care in this case. Okay, it will also take care of traffic. It will also take care of number of revenue, the revenue generated by Apple, because you can see Apple is giving an ad in terms of Google, so that whenever somebody searches Apple, it gives a priority to Apple, which has given money to Google to put it on a priority when it is searching. So this is how you see all the recommendations that come up in the search windows. Okay, and this is very useful if you're starting a startup and you want to figure out where do you want to which website in the area that you're working with you want to put an advertisement on, or which area you want to work more on. So in that way, this becomes much more applicable in real life. So this is a real life application of graph theory in terms of web pages. Any questions on this?
Sir, excuse me, sir.
Yes,
sir,
I believe somebody has a question. Yes, please go ahead.
How to partition this graph, sir?
Partition in the sense you have to condense these multigraphs, right?
Yes.
So you have the condensation algorithm as I showed before, right, in the web page. Because I did not have much time to demonstrate the condensation part. So graph and networks.
Okay.
So in this, you can see there is a condensation algorithm which would factor in what is the closely connected nodes in there. Okay. For example, the nodes in this case, these nodes would create one partition, right?
Okay.
These nodes will create one partition. The central nodes will create one partition, and so on. So in order to get those, you can use this condensation algorithm.
Okay.
Which would separate out these sections in terms of their connectivity and closeness.
Okay, so while partitions are how we find it is a normalized cut or a normalized cut like that. How we find?
Right, that's a good question. So it depends on the function. You can set up the objectives in terms of condensation graphs. You can set up whether it is a normalized data graph that you have to put up, or if it is based on some sort of other algorithm as well.
Okay.
You have complete freedom to choose the choose the rules that you have to apply to any modification to the graph.
Okay, sir.
Okay, I hope that answers your question.
You answered, sir, but still I have a doubt with that normalized cut. While partition, we are telling that normalized. It is a not normalized like that. We are understanding in that cluster format.
Yes.
So in that cluster, how we partition? So here some clusters are there. 4 or 5 clusters are there. From the cluster, how we cut? Like that only I want.
Right. So that is where I mentioned about the rules part, right?
Rules.
So you can cluster them with respect to closeness in the ranks.
Okay.
You can cluster them with respect to closeness with the nodes.
Okay, sir.
Or you can cluster them with respect to a normalized, degree.
Okay.
That is also possible.
Okay.
So that it becomes a distribution, right? So you can cluster it based on, okay, this is coming from this part of the distribution, or this is coming from this part of the distribution.
Yes, sir.
That way was also possible. So these are all the different formats. It depends on the data actually. In this, you can clearly see that we have this classification, right?
Okay, sir.
But usually you won't be having this kind of clear distinction.
Okay.
On that, you will have to define the rules that you have to perform this classification based on.
Okay.
Okay.
Okay, sir.
That would require for us, for example, if it is a biological system, we will see how biological systems would be. Maybe I can just show that also.
Yes, sir. If you have a time, you can show, sir.
Right. So I would just skip this visualize breadth first and depth first search. I can just show you what it would actually give me in the result. So okay, I can't open up the GIF file in this, right? So I have to open outside MATLAB. So this is something that I generated in MATLAB. So with every click, it is showing me which is the path it is taking for a search algorithm, right?
Okay.
So searching is, it can be either you are going through the same level of search, or you are going to one node and getting to the end until the node is ended, and then going back to the second node and restarting the search. So this is to understand how every node is linked. So this is one of the algorithms at the back end where when you're trying to find the shortest path. I hope this makes sense. Yes, so sir. This is already there. This is on how to create this algorithm in MATLAB. I have given it up over here. So on a later time you can actually go through this. So it is on visualize breadth first and edge first. So we have created a function. You can just see how we are just using the same node color and start node, discover node, and finish node to change the colors and process this functionality. I hope that makes sense. Yes, sir. This might be very useful when it comes to exporting things, right? Now let me just show how can we export this. For example, this is the thing that you wanted to work for your project, okay, research. Now I want to export these results in terms of a Word document. That is one requirement, right? What you can do is you can go to the save button. Over here you can see there are multiple options that you can choose. What I did for my research paper is I exported to a LaTeX format and then use LaTeX to add in the references and other points. Otherwise you can just export it to Word document also. Let me just export it to a Word document and show it to you. So now it will automatically open up the Word renderer if you have. So now you can see this entire thing has become a Word document for me, and you can see how it is coming up, right? It is beautifully formatted in the way that you want with the graphs and everything. Sir, I hope this makes sense. This is what you were looking for.
Yes, sir. Yes, sir.
Perfect. So on a personal note, I wrote one of my entire research papers. You can find that on Journal of Molecular Liquids using MATLAB LiveScript. And it is there already. Maybe later on we can see that also, right? Great. So let me just take to the last example because that's going to be a very interesting one. It is a sim biology example. So in this, what we are trying to do is we are trying to replicate something which is found in a paper. The paper is by Elowitz. It's on. I simply put up, it's a biological oscillatory system, which means it is oscillating between states. So it is on proteins. Okay. So what we are doing is we are taking the information which is already given by them. Thank you for that. then we are just, creating a sparse matrix out of it to understand how the data is distributed. Okay, so let me just visualize this in terms of a biograph. So biograph is another functionality that you have just for the analysis of biological agents and biological systems. You can see how this is a complicated thing, and we may not be able to cluster this or condense this, right? We may intuitively say, okay, this might look like a cluster or this might look like a cluster, but we'll see how different it is, right? Because there are reactions that are happening which is linked to this. So you cannot remove these links at all and cluster them together, because if you remove one of these clusters or delink them, there is a possibility that your reaction may not actually occur. So in that form, you have to figure out what is the best criteria to condense. I hope that makes sense. Okay, great. So now we have deployed and generated this biograph. This biograph, I just want to highlight two things. One is there are entities which promotes a reaction in a biological system. This is in terms of E. coli. If you are familiar with E. coli, it is something that causes, food poisoning, right? So researchers were trying to figure out how, how we can inhibit E. coli, or what is the oscillatory behavior that E. coli actually shows in human body. So they figured out there are three different, factors which are causing this, which they called P factors. And then there are other factors which are removing this E. coli from our body naturally. So we just highlighted the factors which are promoting the growth of E. coli in our body. So these are PA, PP, and PC. You can see in three colors, right? Now, once we have done that, we just wanted to check whether there is a cyclicness in this graph. Oh, sorry, if this graph is acyclic. But no, this graph is not acyclic, this is cyclic. So that would mean we can actually start from a node and come back to that node in some of the nodes, okay, not all. Now we have to find how this promoter is actually linked to this promoter. Let's say C promoter. You can see this is the path by which it is reacting and converting and getting interacted with this promoter. So what would happen if I just remove this reaction? That would essentially mean I can stop E. coli from reproducing, right? So that is what we are doing up in the second part. Okay, right. I have to run all the parts. So this is the path. Now, if I remove one of the reactions from this path, what is going to happen? If I remove this reaction from this path, so why I'm showing you this is a very real life example which actually saved a lot of people's life, because we now know exactly how E. coli actually has an oscillatory behavior when it comes to multiplying in our gut. And when the reaction is removed from the E. coli, you can see the entire graph actually changes its form, right? It is quite different from what it initially was. Just one reaction is able to reduce or cluster the data and reduce the population and oscillatory behavior, because of which our medicines can actually affect quite well. So this is a real life example of how this was going into, but I am not going into details of this because this might not be of theoretical background may be missing in this one from each one of us, because we are from different backgrounds. So I'm just going to give you a graph theory importance. The graph theory was able to help us plot this information, find how these different promoters are linked to each other in a weighted manner. Then we were able to figure out what would happen if I stop or reduce a reaction which is promoting the growth of bacteria in our body, and then used graph theory to analyze what is going to happen later on. I hope this gives you a brief idea of why graph theory is important and why it is a very basic subject which is used in many disciplines, but with different names. We call them graphs. Other disciplines may call them networks also. Okay. Great. Any questions on this till now? Okay, great. So let me move ahead then. So that brings us to the last portion of our session. So what I want to end with is we want to be a learning partner. So you already have the platform. The institution already has access to all the tools, all the toolboxes and specialized applications that we have. You 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 already have the people inside who can work on different areas. What we want to promote is how we can help bringing all these people together in a same platform and collaborate and make something new. We will help you with our own expertise. We have a, a plethora of team internally which is ready to help you out if you want to try using MATLAB and Simulink in your research or in your curriculum, and increase the computational thinking. Because a lot of places what we realize is uh, computational thinking, because we are not focusing on that, we may lose the essence of problem solving, and we may garner more of a theoretical knowledge, which is also very important. But with a computational thinking and computational platform, you will be able to apply these theory, which is very useful and powerful, into real life applications. So we have different teams to support you. So we have training team in case if you want a dedicated training in a particular area. We have tools for helping you do guided evaluation. We when the corona was not there, we also had on-site workshops, which is stopped for now, but I believe in near future, once vaccines and everything is out, we would be able to resume these workshops, and if you require any of those, we'll be very happy to do that. We also have dedicated consulting team if you want to do a paid consulting, where we will work with you to solve the problems in a very different manner. Then we have a dedicated technical support team. If you have any small queries, anything that comes up in terms of using MATLAB or Simulink, any bugs, any errors, you feel free to reach out to our technical support team, and they will be more than happy to reach out to you and work with you on that. In case of faculties, researchers and research scholars, or even students, we have a dedicated customer success engineers team, which is my team. We will work with you and ensure that you are directed to the right team and your queries are directed to the right team, and they work with you and ensure that you are able to find a solution, use Mathworks products to find success using this. That's the ultimate idea. You should find success in using Mathworks products, right? So couple of examples of where we were able to help couple of people realize their potential and get to the target areas. So on the left, this is Ronnie Deb. He is one of the founders of Aether Energy. He was a student at SRM University. So he was introduced to MATLAB and Simulink while he was a part of competition known as Formula Student Germany and Formula Student India. And he realized that it is not only about understanding different components of the vehicle, which we do at an early stage, but we also need to put it all together and understand that before building we need to simulate things, right? On the right hand side, on a similar line, we have Abhilash Arora, who is working with Mahindra Electric Mobility. He was able to get through to Mahindra Electric Mobility thanks to the different Mathworks tools that the Mahindra is already using, and Abhilash already had expertise on that. So I believe one of the questions was the job perspectives. So these two, you might feel like these are from automotive industry, but these are just a couple of things from India that I wanted to show. There are a lot more such blogs which are available online. And from an industry perspective, majority of the automobile, aero defense, chemical, petrochemical process, uh, even apparel industries are using MATLAB and Simulink in a plethora of application areas. So if you believe what is the use of learning MATLAB and Simulink, I think these may be very important. And secondary, what more is there is you can also see that in LinkedIn, MATLAB is tagged as one of the top 10 skills by majority of the LinkedIn users, and it is one of the key skills which is also looked at by the placement officers. So I hope that gives you a bit more of the why behind learning or using MATLAB and Simulink. I hope that answered the question that of why. And one thing that we all might be having in our heads right now is how do I get started with, right? So I believe already Jamal and Harish shared where the portal is. I've just put up a link up over here. You can get your own version of MATLAB and Simulink and get started with that. And at the same time, if in case you do not know where to get started with MATLAB in the first place, so feel free to go through all these MATLAB Academy courses. You have access to not only these introductory courses but also on different MAOTS courses, that is MATLAB Academy online training courses. So let me show how it would look like. So if it is MATLAB Academy. MATLAB Academy. So once you log in, so let me just log in using my username and passwords.
Akhil, in the meanwhile, while you're trying to open this, can I just have a couple of words?
Sure, please go ahead.
All right. Yeah. Also, with regards to those on-ramp courses, which Akhil is going to show now, we are planning up a couple of webinars in the coming future, all right, for the faculties and students, all right. And before we go ahead and organize any webinar, we would love to know the areas of interest where and what you would like to learn, all right. So to have this, so in order to get to know the areas of interest, I have created a Microsoft form and shared it in the chat here. Please fill in the form and also share it with the other faculties and students. All right. So once we have a consolidated data of like what they would like to learn, Akhil can plan up a couple of webinars and send out schedule them accordingly. Thank you.
Thank you, Akhil. Right. So the courses I was mentioning, that these are the courses that you have. You also have new courses which have come up as image processing and control design, if you are interested in those two areas as well. For mathematics, computational mathematics, you may have these introductory courses or deep courses. Actually, these are not introductory courses. So you have for symbolic maths, nonlinear equations, differential equations, and for visualizing. That is one of the key areas that I think we all are interested in. That is MATLAB for data processing and visualization. You can get these for MATLAB fundamentals on a deeper scale. You can get this for programming techniques. You can do this course. So we have courses on majority of the areas that will help you out to get started and get a strong grasp of what MATLAB functionalities or how you can, what MATLAB functionalities or how you can use MATLAB to do your particular required process. So I hope it's quite useful for you. I have already hyperlinked these, so you can just click on that and you'll be redirected to these areas. And thank you very much. I'm sorry I extended my session with VBIT. I hope you found it useful, and feel free to ask me any questions you have. I think we can take questions for 5 minutes. I'll stop sharing my screen so that there is a little bit of bandwidth issue up over here. Any questions? Feel free. I think we can take it for 2 to 3 minutes more.
Yes, sir. This is Simon here.
Hi, sir.
Do you have any tie-up with any university? Are you organizing any bachelor degree course or master degree or any research development course?
That's a pretty interesting question, sir. Yes, yes, we are doing that. We are not giving a bachelor's degree course in such, but we are helping in terms of India. We have a link with NIT Calicut. We have created a course with NIT Calicut and Bosch, wherein Bosch has set up a final year course for final year students in electrical and electronics department, wherein they will be doing projects in relevant areas which Bosch is required, and these students, once they show their competency in that, which is more often than not already set because we select in that basis, they will be directly absorbed by Bosch industry. And similarly in research areas, I can show you certain things, sir. So let me put it up in form of user stories. So So these are some of the documented user stories that we have. So education sector, right, sir? So in education sectors, we have these universities where we partnered with them for them to, design or work or bring in certain changes in their curriculum or research. So you can find a lot of these up over here, sir. So some of the Indian stories I would like to highlight would be, if I'm not wrong, there should be a couple of Indian Institute of Science. So there were, mechanical engineering department needed our, started using our tools to find solutions in their curriculum, which was spanning to different domains or different disciplines. That is one. Similarly, for IIT Delhi, their robotics lab was able to create an entire toolbox, which was known as, if I'm not wrong, ReadySim or RoboSim. They put it up over here using that. Yes, it's ReadySim. So recursive dynamic simulator. This looks more of mechanical engineering, but its core is mathematics and differential equations, to be honest. And you have so many other examples on that direction, sir. Like Manipal Institute of Technology. They incorporated MATLAB and Simulink into their curriculum, and they found value in it, and they were able to make sure that there is a competitive edge to students once they are done with the courses and engineering in their engineering or even sciences in their area. I hope this answers the query that you had, sir.
Yeah.
Right. So in case if you're looking for similar interaction with Mathworks, and you can write to me, you can reach out to me, or we can work together some sort of plan where we can we can at least start with the curriculum perspective.
So for that graph theory, how much it is support for analyzing the social networks?
Right, that's a really good question. For graph theory, ma'am, we do not have any set functionalities for a particular area. We have generalized functionalities because graph theory is a very wide area. So a couple of areas where users requested us to have a very specific toolboxes were for bioinformatics and for automobile connectivity, and also for finances.
Okay.
Right, but all of these dedicated toolboxes are also based on the fundamental functionalities which I demonstrated today.
Okay.
So if you have any queries, or if you get stuck anywhere on application in social, social behavioral networking or something, feel free to reach out to us. We'll be more than happy to work with you on that.
Okay, sure, sir. Thank you.
Yeah, let me just show my share my screen for contact information. I hope is my screen still visible by any chance? I hope this is visible now.
Yes, sir.
Right, you can feel free to reach out to us on that particular email ID, any one of us, and we'll definitely work with you, and we'd be very happy to assist you in getting things done. Any other questions?
Akhil sir, thank you for a nice presentation.
Thank you, sir, for the opportunity.
Yes, sir. Can you please tell the background team who are working to produce new products, new features in MATLAB 2020B and future?
Right, sir. That's a really good question, sir. So, the key people who are behind, making MATLAB better or producing new toolboxes are participants like you. So we proactively take your feedbacks onto what are the new requirements that you want us to work on, or what are the areas that we need to better, because there is always scope of getting better in any area. So we take proactive feedback from your side. Then we have dedicated development team in different domains, like if it's electrical engineering or mathematics, or one of the key founders of Mathworks is Cleve Moeller, who is like the closest link to Alan Turing that we have right now. So he's one of the creators or founders of Mathworks, and one of the key creators of MATLAB. So we have experts or experts in all the different domains coming together and considering all the different feedbacks that we get and promote that. So yes, the key directions or feedbacks that we get from users is one thing. Secondary, we do cater to a lot of students. Academia is where Mathworks began, and MATLAB started, from Massachusetts Institute of Technology. So we have a very big place for, academics, and we value their inputs a lot, because academia is always at least 5 to 10 years ahead of industry in form of newer findings. So we try to incorporate the latest learnings from academia in that. And then we have dedicated development team in these areas who will, evaluate and then implement these ideas into reality. And then we have the customer success team, customer success specialist, to let you know of what new things have been formed and how we are, moving ahead in that particular area. I hope that answers your question, sir.
Yes, sir. Akhil,
Yes,
I have
sir.
one more couple of questions. The one more question is, when I try to find a power 300, suppose a is a matrix. If I want to find a power 300, whether this MATLAB has a solution, because 1 year back I tried, I could not able to get the right answer. That's the first question.
Sir, could you please repeat that, because I was not able to capture that?
So if I have a matrix, 2 by 2 matrix or
Correct,
3 by 3 matrix, finding the power of matrix, what will be the solution if the power is n is equal to 300?
Okay.
When I tried with the help of MATLAB, that I could not able to get the answer.
So
therefore, there is a limitation. Can you talk about the limitation of MATLAB?
Sure, sir. First, let us try the example that you mentioned, right, sir?
Yes, sir. You please try with an example. Take our square 2 by 2 square matrix,
right,
and find the power 250. Maybe you will get the output, but more than 250, I think we are not able to get the output. Why?
So let's say a to the power of 500. It becomes infinity, sir.
Yes, 500 is a small number, but when we raise a matrix to the number 500, but we cannot get the output. So there is a limitation for Mathworks software also.
So if it is possible, can you please tell me a matrix that I can create so that we don't get an infinite thing?
No, so finding a power of a matrix it's going to be a finite value only. It won't take to infinity. Maybe the software not able to find the product.
Right, sir. Okay, I understand what is coming up, sir. So, sir, any software or any computational tool would be limited by the maximum number that it can show, which in current time is 2 raised to 32, if I'm not wrong.
Okay.
Hello, sir.
Okay, sir. Number of operations you're talking about.
So the maximum value it can show. For example, because this is stored in computer memory, right, sir? Yeah. So we have 64. Oh, sorry, not 2 raised to 32, sir. 2 raised to 64. So the double type of variable, which is the largest number variable that you can find right now, is a 64-bit class. So what happens is by physical limitations of a computer, 64-bit would compute to approximately 2 raised to 63 n minus 1. 2 raised to 63, up to that number it can compute. Anything beyond that, it would say it is an infinite number, or you can put it in terms of a scientific notation.
Okay, sir.
Right, so
and the next one,
let me just put it.
My second question is.
Right, sir.
Yeah, my second question is recently Professor Solo from USA, who has introduced a new matrix operation, and he introduced a new subject. The name of the subject is the multi-dimensional matrix theory,
right,
where we get multiple layer of matrices
He
Correct,
has
sir.
introduced addition, subtraction, multiplication, and inverse of the matrix, power of the matrix, and so many theory he developed. But till
Right, sir.
now, the Mathworks has not produced the toolbox for this operation. Can you update the latest status?
Yes, sir. So MATLAB release notes is one of the areas where I wanted to perform this on. So this is because this is something that came up in 2020B version. So let me just stick to 2020B. Let me go to mathematics. So this is the hypermatrix or what do we say, multi-dimensional matrix manipulation functionalities that has been added up in MATLAB R2020B. So it includes multi-dimensional excuse me, sir.
Can you share your screen, sir? We can see only your contact information.
Oh, right. I'm sorry, sir. I think I would have shared only one screen. So let me just show it. I hope this is visible, sir.
Yes, now visible.
Right, sir. So the page times and page transpose, page inverse, these are the new functionalities which came up in MATLAB 2020B release, which functions or implements transpose, multiplication, etc. on a multi-dimensional matrix. So these are the functionalities that have come up based on certain rules. It is also possible for complex matrices, sir. So you can see this is a matrix with 3 layers of complex numbers, right? And these are all mentioned, sir. And according to along with that, they have complex conjugate transforms, or it is m times for power transformations. That is also possible, sir.
Thank you, sir. Thank you for the information, because I tried before 1 year that I could not able to find
Right,
a help menu to. Now it is available in 2020B. Thank you for the information, sir.
No problem, sir. I'm very happy to let you know of this, because as and when we get feedback, like as I mentioned before, we try to proactively bring it up as soon as possible. Any other questions? Sir, I hope I was able to answer your query.
Yes, audience, do you have any question? Please raise. Thank you, sir. Thank you so much. The audience can post your questions in the email ID given by Mr. Akhil. And this session is recorded, and this video will be sent to other students who have not attended the program. And if they have questions, they will also contact the Mr. Akhil through email ID. I request Aman Swami, student, second year student, CEC department, to give vote of thanks.
Hello.
Yes, Aman, go ahead.
On behalf of Hindustan Institute of Technology and Science, I take this opportunity to propose the vote of thanks to our Chief Guest Chancellor, Dr. Mrs. Elizabeth Verghese, for gracing this webinar, the management of Hindustan Institute of Technology and Science, distinguished guests, Mr. Harish Murthy, Mr. Akhil Gopinath, Mr. Mohammed Awais Jamal, for the interactive, informative, and knowledgeable sessions. A lot of takeaways to the students of Hindustan Institute of Technology and Science. I would like to thank Pro Vice Chancellor Alexander Jesudasan, Dean Academics Dr. Vasudevan, Dr. Ramesh Babu, HOD Science, School of Science and Humanities, Assistant Professor Dr. Simon Raj, Professor Dr. P. Ranjana for their moral support and guidance for conducting this informative and knowledgeable webinar. Lastly, I would like to thank my fellow students for the active and overwhelming participation to make this webinar a grand success. Once again, I thank you all for your cordial participation. Thank you.
Thank you so much.
Aman.
I request all the audience to fill up the form, feedback form, as well as the form shared by Mr. Harish Murthy. Thank you. Thank you for sharing your time with us.
And
a special thanks
thank
to
you, Simon.
The Mathworks team for making this program a grand success. Thank you so much, sir.
Thank you, sir. Thank you, Simon, sir, for coordinating and organizing this. Right, in a great way. And thank you everyone for being a part of this onboarding and making this interactive. And thank you, Akhil, for the wonderful session. Right, I would like to thank everyone today. Thank you. And please feel free to reach out to us in case if you have any concerns, and we can address it in a timely manner. All right. And our contact information will be shared. And also you may take it from Simon, sir. Right. Thank you, sir.
Thank you, sir. Harish, sir, I have, as I already spoke about this, the month of January 2021, we plan to have a 3-day workshop. We request to give the speakers from your side. And
yes,
the details I will share with you through email.
Sure, sir.
Yes, sir. Thank you so much, sir.
Thank you, sir.
Have a nice day, sir. Bye, sir.
Thank you.
Have a nice day, everyone. Thank you. Bye.
Thank you, sir. Thank you, Akhil, sir.